Okay, so this is proper maintenance on our CBC machine. I'm going to show you how to do general maintenance, which would be like cleaning the wash head. So that's what I'm going to do today. What you'll do is open this side of this machine and it'll tell you when it's ready, and there's a wash head that you clean off. And then it'll get all the gunk off of it or any like clotted blood or anything like that. So what you do is you get a damp cloth and you gently wipe off the wash head, make sure that it's free of any debris, and then you close your door back and you hit done, and that's all it is. Okay, so this is my ELISA test that I'm doing. I'm going to do a canine snap, and it'll show you whether the dog is heartworm positive or any 3 types of tick fever positive. So what you do is you're going to add 3 drops of your blood and make sure that it's not clotted. And then you'll need 4 drops of your conjugate. You will invert the tube just a few times to get it mixed up, and what you'll do is you'll put it in this well. The blood will go through, and once it hits the circle mark, that's when you snap it, and the test will run for 10 minutes. Okay, now that the blood is starting to go into that bottom circle, you just snap it and then start the timer for 10 minutes. Okay. So our canine snap is negative. The control is up in the upper left-hand side. If it were positive, there would be another dot somewhere throughout the test, and then we would go from there, whether it's heartworms or Ehrlichia or any of that. So we're going to do a modified knots test. We need 1 ml of anticoagulated blood and 9 mils of formalin. So I added my 1 ml of blood in here. I'm going to do my formalin. You will put the lid on and invert the tube several times. And then we're going to centrifuge it for 5 minutes on 1500 RPMs. So now that I have centrifuged my sample for 5 minutes, we need to discard the rest of this sample and not disturb the pellet at the bottom. Okay, and now that we have most of it off, what we need to do is take 1 drop of the methyl blue stain and drop it in there. And then we need to mix it up carefully. We're just gently mixing up our sample. And then what we need to do is get 1 drop of blood and apply it onto our microscope slide. So just 1 drop of blood, and then we will cover it with our cover slip and look at it on the microscope. Okay, what we're checking for is microflora of heartworms. So we're going to start out at our lowest magnification on 4. And we're going to scan all areas of the slide. and you may need to bump it up to the 10 magnification and adjust it. And after looking, I don't see anything of concern. Okay, so we're doing our fecal portion of our video, and it's really important to do fecal floats because you find all kinds of intestinal parasites like whipworms, roundworms, tapeworms, the whole 9 yards. So we're going to start out with a fecal float. So you're going to take 2 to 5 grams of your fecal, and you're going to add in your fecal solution. You're going to mix it up really well. It's really important to wear gloves, obviously, for sanitary reasons. And then once you have all of the fecal mixed up to where the bigger parts are broken down, you're going to take a piece of gauze, and we're going to strain it into a new tube. So you're going to come this way so you can see what's happening. So now hold it like this, using a piece of gauze in a new tube. I'm going to strain this. Okay, once you've strained your solution, what you're going to do is take your fecal solution and fill it all the way to the top to where there's a meniscus that forms, and then we will cover it with a slide and wait 10 to 15 minutes, and then we can view it. So we're going to do a sedimentation fecal now. So what we're going to do is add a little, like 2 to 5 grams of the fecal into a cup, and then what we will do is add tap water to it, and then we're going to mix it together to break up all the large pieces. This kind of fecal is done mainly in large animal because the eggs are too heavy to float to the top. So I'm going to mix up the large pieces. Okay, once you've done that, you're going to take a smaller container and you are going to strain this mixture into a smaller container, and then we'll let it sit for 30 minutes, and then we'll come back and pipette off the top. Okay, so we're going to let it sit for 30 minutes and then come back to it. To finish up our sedimentation float, we've let it sit for 30 minutes. We're going to pipette the liquid off of the top and be very careful not to disturb the sample at the bottom. And once you have most of it off, you'll take another dropper and you'll get the sample, or the top, right off the top, and then you'll take a microscope slide and you'll apply one drop onto the microscope and then apply your cover slip and you are ready to read it. And that's how you do a sedimentation fecal sample. Okay, so we're going to do a direct smear. What you want to do is take a small amount of the fecal sample and you're going to directly place it onto your microscope slide. This is like an easy method, but it's not very accurate. You don't want it to be very clumpy, and you just want to smear it across to where there's no issues. And then what you'll do is take like a drop of saline solution and apply it to your slide, and we'll mix it up a little. You don't want very big chunks in it. And then you apply your cover slip onto the top of it, and then you can view it under the microscope. And that's how you do a direct smear. Okay, we're gonna do a fecal float using our centrifuge. So we're gonna take like 2 to 5 grams of our fecal sample. And then we will add our fecal solution into it. Now we're going to mix it together to try and get most of the big chunks that we can broke up in this cup. Then we will take a little centrifuge tube, and I've made a makeshift strainer for it. So I'm just going to pour it in the top of this. Okay, and then we will centrifuge it for about 5 minutes. Okay, now that we've centrifuged it for 5 minutes, we're going to add more of our fecal solution and make it to where there is a meniscus on the top, and then we will apply our cover slide. Okay, you show that. And then we'll apply our microscope slide and then let it sit, and then we can read it. Okay, this is how you perform an ear cytology. What you'll need is your patient, and then you'll need 2 of these. I've just got this one right now to do her right side. It's a culture swab, and what you'll do is, just gonna throw that in here. You'll remember that you're doing, what side you're doing. I'm sorry, yeah. And you'll swab out the ear. Okay, so I did her right side, so I'm rolling it on the right side of the slide. You just gently roll the swab across it. You don't want to tap it on there or like really hard press it on there so that you don't mess up anything that you might be able to see on the microscope. Okay. Now we're going to do her left ear. It's important that you do both ears just in case one ear has something different than the other. Oh no, I know. I'm so sorry. Oh, yeah, I know. Okay, and now what you're going to do is roll this one on the left side and gently roll it, roll it. Okay, so to prepare the slide before you stain it, you have to heat it up. So just run it under a little bit of heat. Okay, so once you've heat sealed your slide, what you're going to do is stain it. You're going to do 10 dips into your first, your second, and your third. So we're gonna start, you start with the lightest color mark to the bigger colors. Okay, and then once you've done it 10 there, just blot off the ends. Same thing with this one. Okay, so once you've done 10, we'll just blot off the ends of this. And then we're gonna wash off the back side of the slide. You don't do the front side, obviously, because you don't wanna lose your specimen that you're looking at. And then dry it off. Okay, once your slide is ready, you're gonna put it under the microscope. We're gonna see what we can find. You're going to start out at your lowest setting, which would be our 4. And we're going to get it focused. And then if you have to, you can go up to the 10 setting and get it focused in. It is very apparent that she has ear mites. Okay, we're going to do a fungal test on a dog that is known for having skin issues. I have a DTM test in my hand. What I'll do is get 10 to 20 hairs from around the lesion, but not exactly on the lesion. And then I'll put them in the jar. I'll leave the lid lightly on, and then we'll keep it in a dark, cool place for the next 7 to 10 days and then read the results. So. Now that I have the 10 to 20 hairs, I'll just put it inside here and we will go from there. Okay, so we did the fungal test on our dog about 7 days ago, 7 or 8 days ago. We've checked on it daily. The color has not changed. If it were to be like a dermaphyte, it would change to a dark, dark red color, indicating that you would have like ringworm or an issue. This one hasn't changed. We'll keep an eye on it for the next few more days, but for now it's negative. Okay, so to do a skin scrape on a dog, you're gonna need a microscope slide with 1 drop of mineral oil on it and a blade. It's important to keep it at a perpendicular slant, and you're going to scrape the area, and you usually pick an area where there is hair loss, and you do this in case a dog is prone to skin issues. You just want to get past that first layer of epithelial cells and kind of make them bleed. Okay. And then what you do is take your slide and gently roll it in the mineral oil. So once you have done your skin scrape on your dog, you don't stain it, you go directly to the microscope, so that's what we're going to do. We're going to start out on our lowest objective, which would be 4. We are going to see what we can see at this objective. We'll get it focused. Go from there. So on skin scrapes, what you're looking for is like Demodex, the mite, or like mange. Demodex has what we call a cigar shape look to it, or almost a submarine shape. Okay, we're going to go up to our next objective, which would be 10, just to get a closer look. You want to check all areas of this slide to make sure you don't miss anything. And you want to check dogs that mainly have chronic skin issues. And if they do have Demodex or anything like that, you'll want to skin scrape them each time you see them. And it looks like this dog actually does have Demodex, so we would treat that once he wakes up. So that's how you do a skin scrape on a dog.
Okay, we are necropsying a bird. Let's look at the external wings. They look good. Wings. Looks like we have trauma. There's blood on the external surface. Turn this baby over. Little neck's broken. Feels like. Okay.
Do you think the wings normally?
Oh, I think they're
Good.
good. Okay, let's open this baby up. Midline. So we're going to go through the keel.
So many feathers.
Yeah. Let's get this one.
And the whole one's in.
There we go. Yeah, I would. Keel.
So many
Feathers. Sterilize this bird. I'm going to try to go into the let me see if I can go and open. There you go. Thank you. That is the keel. Let's go down here. Lots of feathers.
Mm-hmm.
Okay, now we go and see the air sacs.
Oh.
Okay. Okay. Lots of feathers. Okay, I'm going to let you see if you can sterilize.
Oh, that's nasty.
Okay, this looks like part of the liver. And we need to get a part of that for dissect culture, correct?
Mm-hmm.
Okay. Let me do this, just so I don't have a contaminated, and everything's got feathers. Grab me another, give me another scalpel blade.
Ew.
Thank you.
Oh, I'm sorry.
I'm gonna take these off full of feathers
I'll
and
just
get
keep
some
holding the
plain ones
bird.
on. Okay. Okay, so I'm gonna get a piece of the that's the liver.
Oh, yuck.
Okay. I'm going to get some of the this looks like okay, and let me get some of this GI tract.
Okay.
Okay. And just
You want more than GI tract?
no, I think that's
Oh, my lands.
good. Thank you.
Mm-hmm. I'll hold it down.
Okay, let's go ahead and put this in there with this one.
Okay, Dr. Lindley necropsied the bird for me, and then I labeled all of the jars according to what it was, and then I added the formalin to it. That way it can be preserved and be sent off for testing. Okay, so to handle a rabies suspect, only the doctor and vaccinated personnel should be handling the rabies suspect. The protective gear that you need on are like face mask, goggles, your gown, gloves, everything to protect your body. The sample that the lab needs is the brain or the entire head to test for rabies. The sample has to be bagged, and then we bag it again and put it in a styrofoam box, and it has to be shipped on ice. It needs to be labeled correctly, and it'll have a labeling slip, a packing slip that'll go inside with it. And then while we're waiting for the results, the sample body needs to be correctly labeled and correctly put up in an appropriate place where nobody else will mess with it. And then if it is negative, then it can be disposed properly. Okay, so today we're going to do a vaginal cytology. It's very important that we clean the area with a sterile saline. So I'm just going to work the area, clean around it. And then it's very important that we get the swab moistened as well with just a sterile saline. You're going to insert it at a 60-degree angle. You're just going to roll it around gently. Yeah, that's okay. Okay, and then what you do is roll it on the slide very gently so that you don't mess up any of the cells. And then we will let this air dry and stain it. Okay, so now that our slide has dried, we're going to stain it. It's going to be, dip it in each of these stains 10 times each. So what you'll do is off the excess. Oh, jeez. Okay, and then we'll let our slide dry and then we will look at it. Okay, so now that our slide has dried, we're going to stick it under the microscope and see what we see. You're going to start out at your lowest magnification, which ours is 4, and you will get it focused from there. And then once you get it focused, you can move up to the 10 magnification. There's 4 stages of an estrus cycle for a dog. You have your proestrus, where you'll have mixed cells with red blood cells. Your estrus, which is when they become receptive to the male, and you'll see more like flattened epithelial cells. And then you have your diestrus, which will have more basal cells. And there will be a lot fewer red blood cells. And then you have your anestrus, which you will just have more basal cells from there. So, judging by these cells, I would say that Piper is in proestrus going into estrus, because some of her cells are losing shape and there's a few red blood cells in there. And that's how you do a vaginal cytology. So to do a cross-matching, we have drawn on 2 separate dogs. We have our donor dog Ubu, and our recipient Honey. We have drawn blood to put in clotted tubes and our EDTA tubes. So the first step that you're going to do is centrifuge your clotted blood samples. So we're going to do that first. Across from each other so that they are evenly weighted. We're going to centrifuge that first, and then we will move on to the next step. Okay, so now that it has spun down in the centrifuge, we're going to draw off the serum off of the samples, and we're going to put in a new red top tube. So I'm going to do that now. So that was for our donor dog, Ubu. And then we're going to do it for both of the red top tube samples. So that way this new red top only has the serum in it. Okay, now that we have done that, we are going to spin down our EDTA tubes in the centrifuge, and then we'll move on to the next step. Okay, so now that our EDTA tubes are spun down, we are going to take the plasma off and put it in a new red top tube for each of our dogs. We'll start with Ubu, our donor dog. We will get the plasma off of this. set this tube aside and this tube aside. And then we're going to do it for our recipient dog. Getting the plasma off of this as well. I'm using it wrong. This one's bigger. And then we'll set it aside. Okay, so what's left in the EDTA tube would be the erythrocytes. So what we're going to do is take 1 to 2 drops of each dog's blood, and we're going to place it in a larger red top tube, and we're going to fill it with a sodium chloride saline solution, and then we will centrifuge it for 1 minute at 3,400 RPM. So that's what we're going to do now. So I have our donor dog Ubu now. Get everything set up. This is just the solution. We'll take 1 to 2 drops of this blood here. Set that aside. And we will add the sodium chloride solution. Then we will gently agitate it and then stick it in the centrifuge and then do the other dog. Now we will do our recipient, which is Honey. Same thing, 1 to 2 drops of blood. Pull it back to this because I made a mess. And then the sodium chloride saline solution in here. Okay, and now we will centrifuge it for 1 minute at 3,400 RPMs. Now that we've spun it down for 1 minute, you can see that it's clear. We're going to decant the supernatant off of it, and then we will do the same cycle over again with the sodium chloride rinse solution. So I'm going to go ahead and do that now. This is off of our donor dog Ubu. Big enough to pull. Okay, now we will set this aside. Or I guess we can go ahead and add the saline solution again. So we're just going to fill it up again. This is our donor dog, Ubu. put the lid back on it. You can see that it's mixed back up. We'll gently agitate it again. And then we will do our recipient dog honey. And hers is clear as well. Okay, now we're going to wash the erythrocytes again and spin it again, or centrifuge it again for 1 minute on 3,400 RPMs. So this is Honey, our recipient dog. Okay, so this was our second time to centrifuge our samples. They're clear again. We're going to decant the supernatant off of it again, and we will wash the erythrocytes one more time, and we will go from there. Okay, we're going to go ahead and wash the sample one more time. And gently agitate it again. So I'm going to go ahead and put it in the centrifuge. So I'm going to do my other one. It's clear as well. Now we will add our saline solution to this one. We will gently agitate it again and centrifuge it for 1 more minute. Okay, now that we've done our last centrifuge, we're going to decant the supernatant this last time, and then we aren't going to add a saline solution into this. We'll take 0.02 of the erythrocytes and put it in a new red top tube, and then we will add 0.98 of a saline solution into that red top tube. So I'm going to decant this now. And we'll do it for both our recipient and our donor. Right now I'm doing the donor. I accidentally agitated my sample, so I respun it down with the centrifuge. Now I'm going to decant this pertinent off of it again. And I nearly did it again. This is our donor dog still. Okay, now we will take a TB syringe and we're going to get 0.02 of the washed packed erythrocytes. Okay, and we will add it to our new red top tube. And then we will add, let me put this over here, 0.98 mils of the saline solution into the new red top tube. And this is all on our donor dog, Ubu. And then we'll put the lid on it and mix it gently. And then we will do our recipient dog, which is Honey. Go ahead and take this lid off. Set these out of the way. And this is Honey's after the third rinse. So we're just going to decant it. Okay, and we'll do the exact same thing. We'll take the TB syringe and get 0.02 of our packed washed erythrocytes. Goodness. This over here. Now I'll add my saline solution and we will mix it gently after that. This is 0.98 mils of saline solution. I'll mix it gently. Okay, so to make the control for a cross-matching test, what you're going to do is take your last erythrocyte suspension that we just made and the serum of the donor dog. You're going to take 2 drops of each of them and we will mix it up. So I have a new tube with Ubu's name on it and control, that way I don't get it confused. And mix this up one more time. We're going to take 2 drops of this sample, which is our erythrocyte wash. And then 2 drops of our serum. And put it in the same red top test tube. And then we will do the same thing for our recipient dog. So this is Honey, our recipient, with control roped on the side. This is the erythrocyte wash that we just did, and we'll take 2 drops out of it. And then we will take Honey's serum that we have and add to the same red top test tube. And we will agitate it. Okay, so to do our cross-match major, what you're going to do is take 2 drops of your erythrocyte mixture from your donor dog and 2 drops of serum from your recipient dog and put them in a test tube. So I'm going to do that now. I have Ubu's name on there with major, that way I know. Set these aside because they're used. So I'm going to take 2 drops of our erythrocyte mixture. And then 2 drops of serum. Agitate it gently. Okay, so to do a cross-match minor, what we're going to do is take 2 drops of the donor serum and 2 drops of the erythrocyte mixture of the recipient and mix it together for a minor cross-match. So I'm going to go ahead and do that. This is a new test tube with it labeled so that we know. So this is our donor serum. We're going to take 2 drops of it. And then 2 drops of our erythrocyte mixture. We'll gently agitate it, and then we will let it sit for 30 minutes at room temperature, and then we will come back to it. Okay, so now that our control, our major, and our minor solutions have set for 30 minutes at room temperature, we're going to centrifuge them each all together at one time for 1 minute at 3,400 RPM. So I'll go ahead and do that, and we'll want to get them set up in the centrifuge to where it's evenly weighted. So I'll go ahead and do that. And then we will will centrifuge it for 1 minute and come back to it. These are our controls. There's no disturbance in them, so that is a good thing since it is their own erythrocyte mixture and their serum. However, this is our let's see, our major, and there is some disturbance in there, so that means that they could not be compatible for a blood transfusion. Even our minor has a reaction. And that is how you do a cross match.